Are you with me? Now, we say the echo velocity or velocity of echo is simply 2x over t. Why is it has to be 2x? Because echo is established when the sound goes and then it's being reflected back to the source. Is that taken now? So from here to here is 1x, then back is what? Another x. So when you add that up, what do you have? Do you understand? So there is one question there. Let's quickly solve that and move on. The first question, they talk about a boy. Please, let's carry others along.
A boy received the echo of his clap.
A boy received the echo of his what? His clap. Yes? Reflected by what? A nearby hill. Let's assume that this is the hill. And this is the boy. This is the clap. And then he hears this back after what? 0.8 seconds. Very good. So how far is the boy from where? From the hill. So what are they asking? X. Hello? Good. So what are you going to use since they have given you the velocity to be what? Velocity is what? 3, 4, I gave you something in brackets. 340 meters per second. Then you impute it. I believe somebody can do that now. So all you need to do is just say V is what? 340 equals what? 2 times X over the time, which is what? 0.8. Then you cross multiply. What are you going to have? You have 2x now equals 0.8 times 340. Then divide both sides by 2. 2 in 3 is 1. 2 in 40 is 7. So 170 times 0.8. So 8 times 17. Give you your answer in meters. 136. 136 meters. Okay? 136 meters. That's the unit for distance. So which means the boy is keeping about 136 meters away from the hill. So that is gone. Now, this is the machine, this is the machine, and you have your water. So by the time the same sound, are you with me? Into this medium, which is your what? Your sea or ocean. Of course, what happens? When you have either octopus or whale, it will reflect back because it's a body. It's a what? It's a body. So it will reflect the fact with the same shape. That's how it will reflect back, and that's when they will tell you from the ship that there is what? Octopus under us. There is whale under us. Do you understand? So it's a technique. It will reflect it back. And again, as they send it, they compute the time with which it hits the bed or the base of the ship and then comes back. Now, for your audible range, you may likely not to hear it physically, but we have some machines that are so much sophisticated, well designed that they are sensitive to what? To pick these signals back. Are you with me? So they will give you detailed information. So don't think that because you cannot hear it, it does not happen. Is that taking now? Good. So it will come back. So they calculate the time it takes for it to come back, and they will tell you using that same word formula. They will get it. They will tell you how deep it is. They will tell you, are you with me? Very good. So therapy. There are some, in some industries, there are some points that humans cannot reach. When you see heavy duty machines being coupled up, what I say, being coupled up in such a way that by the time they run, all those machines, they run with 3 phases. What do I call it? They run with what? 3 phases. We have 1 phase to our houses. Of course, you may see like 4 cables entering our house. That's 3 phase, but you only use 1. Are you with me? If you see 3, that is 2 phase. You only use what? 1. That's when you see some people, they will say they change their line from one to another. But these matches, these industrial matches, you have to combine all the 3 phase together to power them. Are you with me? Yes, you don't know. Okay. Even welding what do you call it, wedding workshops here, you will see that there is this NEPA, I mean the commercial power, yet they will be wedding and you'll be seeing it dropping. Are you with me? That's to tell you the magnitude of the power they are consuming. So when you start running, of course it will be generated, right? So there are some points that you cannot reach as humans. Do you understand? So they use this technique to scan. When they sense sound, it will scan for every reflecting body. Even if your ring is somewhere thrown into a part of the what, of the machine, when they use that technique, it will scan it out. I will tell you the distance, the point, the exact point where you have what, that ring, because you have one reflection. Are you with me now? They use this for scanning too. Ultrasonic therapy. They use for scanning. Okay, now to see your baby and the lights, frequency of sound. Anytime you make sound and the sound is periodic and it's regular, it is automatically going to be pleasing to your what? To your ear. Are you with me? And that's music. It does not really have to be voice. Hello, it does not have to be what? Voice. It could be a pen that you are striking, in as much as it is periodic. Are you with me? Now, what about beat? Don't mistake beat for music or musical notes. Beat is when you relate two sources, just what? Two sources that have almost the same frequency of sound. Almost what? The same frequency of sound. We call it what? Beat. And how do we calculate it? We say beat is equal to the frequency of the larger one minus the frequency of what? The smaller one. Do you understand? That is just beats. In case they ask you, calculate beats, just get the frequency of this, then the bigger one, subtract. That is beats. Is that okay now? For instance, if I do something like this, that's periodic, right? Then that's beats. Do you understand now? So I'm putting this, you are related, then you begin to what? Yes, and you can predict the next time I will have what? My sequence. And that's what? That's beats. Is that okay now? Good. Then, what is noise? Noise is the reverse of what? Music. When you have sources of sound making frequencies that are irregular, that are what? Irregular, very irritating. For me to drag this thing now, the legs of this tripod will drag against what? The ground with some annoying frictional forces, and then give some provoking sounds. If I should drag this thing now and you know, and so these are. Now let us now see how waves